What's up guys, Huzaifa here, and today we are talking about how to use mathematics to help you win a game show. This is really cool, a really cool application of math, so how you can beat a system and win a prize instead of a goat, and I'll get to the goat in a second. So what we're talking about today is a game called Let's Make a Deal. It used to be hosted by a guy named Monty, and basically, let's say you go on a game show. Let's say you're on this game show, crowd, audience, they love you. They're kind of waiting in anticipation to see what you're going to do. And the host of the show comes to you and he says, okay, here's the deal. We have 3 doors, all right? And we're going to label these doors 1, 2, 3. Now, behind these 3 doors, we have one prize. Okay, and that prize is a car. In this case, the modern version, we have a beautiful R8, my favorite car. But behind the other 2 doors, behind doors number 2 and 3, in this case, we have a gag gift. We have a goat, which you actually may want if you're an animal lover. But the whole point is it's a gag gift. You don't actually get to keep the goat. You don't get a goat gift or pet. So you really get nothing. Now, this car could be behind door number 1, could be behind door number 2, or door number 3. We don't know. All right. So now the doors are closed. We have no idea what's going on. The question is this: if you choose, let's say, door number 1, before the host reveals that, hey, you either won or lost, he says, well, I'm going to do you a favor. I'm going to tell you that the car is definitely not in door number 2. So now he's telling me it's definitely not behind door number 2. The question is this: do you stick by your guns? Do you stay with door number 1, or do you switch to door number 3? Now, when I first looked at this problem, I just thought, hey, of course, it doesn't matter. You can switch or you can stay, because really what's happening is now you're coming down to a position where you have 2 potential doors, because one of the doors is eliminated. So you can stay or switch. You got a 50-50 chance. It doesn't matter. But that's not actually how it works out. Okay, and this is a really strange case. So that is the question: is do you keep your original door or do you switch? You ready for the answer? Here it comes, and I'm going to give you a little spoiler. You should switch every time. Believe it or not. It's counterintuitive, but your odds are substantially higher. So what are we talking about here? We're talking about probability. What is probability? Probability in a game is just the number of ways you can win over the total universe of outcomes, the total different ways that this thing can unfold. All right. So we're trying to see why switching every time will give you a higher probability, a greater likelihood of winning. Basically, more ways to win than if you were just basically staying with your original choice. So let's jump right into it. So now let's go back. We've got our doors 1, 2, and 3. We don't know where the prize is, but we're gonna have to actually look at 3 different possible layouts. Why is that? Well, because we have to account for the fact that, hey, the car could be in door number 1. Well, the car could also be in door number 2, but the car could also be in door number 3. So now we have accounted for every single possible breakdown of where this prize could be: 1, 2, or 3. Now we're going to look at each one individually, and we're going to say that every single time we're going to choose door number 1. So let's go ahead, and we've got our first scenario where the car is behind door number 1. So in good form, just based on how we set up this experiment, we're going to choose door number 1. The host says, hey, it's not behind door number 2. He could have told us it's not behind 2 or 3. It doesn't matter. He says, hey, it's not behind door number 2, but we're going to stick to our guns. We're not switching. We stay, hey, and we win. Congratulations. So you just win a new car in this case by staying. So far we're 1 for 1. Now let's go to scenario number 2. Here the car is behind door number 2. We're switching door number 1. We got the goat. And the host says, hey, but guess what? It's not behind door number 3. We don't care. We're going to stick with our original pick. Ooh, and in this case we lose. We get the goat. We get the gag gift. No good. All right. Scenario number 3. Now that car is behind door number 3. Again, choose door number 1. Host tells us it's not behind door number 2, and we don't care. We stick with door number 1. Boom, and we lose again. So how does this balance out? What happens here? when we kept our original door every time, we won simply 1 out of 3 times. So that was our likelihood of winning, 1 out of 3. Now let's see what happens when we switch every time. So again, we got the same 3 different scenarios, 3 different breakdowns. And so we've got this, everything is the exact same. So now we're gonna start again in this first case where the car is behind door number 1. We choose door number 1. Host tells us not in 2, and we switch, because we're gonna switch every time. There's no other factors in play other than simply switch, switch, switch. It's not based on the tone of the voice of the host, nothing. So we've switched, we lose. So far we're 0 for 1. We're already in a worse position. Let's go to scenario number 2. So now again, we choose door number 1. Host tells us, hey, it's not behind door number 3, by the way. Let's switch. And we're gonna switch, and guess what? It works. We switch to door number 2. We get the car. Ta-da. Good. Now you're 1 for 2. Okay, so now it's all coming down to this last scenario to see which one is better, or are they the same? So now we come down, and we're again starting with door number 1. Okay, the host tells us, hey, no door number 2. What do we do? What do we do? We switch, because that's what we're doing every time here. And guess what? We win. So what happens here when we switch every time? Now, compared to 1 out of 3 times where we're winning 2 out of 3 times every time. That's a 33% chance of winning versus a 66% chance of winning, roughly. I rounded. But 66%, 33%. So we basically got double the chances of winning if we switch every time. So the short answer is you should be switching every single time in this particular game if you're on. Let's make a deal with Monty Hall. All right, I hope that was fun. I hope that was interesting, and I hope that made everything clear for you as far as why you should be switching doors every time in this case. Again, I was your host, Huzaifa. Hope you enjoyed it. Please comment below, subscribe below if you like this video. Thanks so much. See you guys next time.